Okay, hello everyone. Today we are looking at how to find missing lengths in right angle triangles when we have an angle present. We've seen previously to find missing lengths in right angle triangles when you have two lengths, you can use Pythagoras' theorem. However, today we're looking at questions where we don't have two lengths, we only have one length and an angle. And for this, we have to use trigonometry or SOHCAHTOA. SOHCAHTOA is a set of formulae which you can use only in right-angled triangles. Now, in front of us, I have our general right-angled triangle that has been labelled with three key lengths for a right-angled triangle, which is the hypotenuse, the opposite, and the adjacent. And for this, we need to just quickly recap how to label these lengths in a right angle triangle. The easiest is the hypotenuse. The hypotenuse is always the longest length and it's always opposite the right angle. Now, the opposite and adjacent depend on the angle we are dealing with in this case. Over here, this is the angle we are working with in this question. So the opposite is the length that is opposite that angle. This is the length that's opposite that angle. It's not the two that are next to it, it's the one opposite. If, however, I was working with this angle over here, the opposite would have been this length here. The adjacent is the one that remains, but adjacent just means next to. So if this is my angle, there are two lengths next to my angle. One is the longest, which is the hypotenuse. The other one is the adjacent. So those are our three lengths: the hypotenuse, the opposite, and adjacent. And from these lengths, we can generate three key formulae or three key ratios. The sine of an angle is the opposite divided by the hypotenuse. This is always the case for any right angle triangle. Cos of the angle is the adjacent divided by the hypotenuse, and tan of an angle is the opposite divided by the adjacent. This is always the case due to similar triangles. Now, I have for us three questions to help us work through this style of questions and just to give us an understanding of how to work through this topic. Now, we've said the first thing whenever you're doing any question for SOHCAHTOA is you need to make sure there is a right angle present. You cannot use SOHCAHTOA if there isn't a right angle. You can see there's a right angle here, a right angle here, and a right angle here. We also said you need to be dealing with an angle at the very least. We have an angle here, an angle here, and an angle here. So when you are doing a question where you're finding missing lengths using SOHCAHTOA, the first thing you should be doing is to label your triangle. I always start with the longest length, which is the hypotenuse, which is the 8 centimeters. I'm going to underline it because that's what we're looking for in this question, or that's what we're working with in this question. The next length I can underline or identify is our opposite. Our opposite, OPP, is the value of P. That's the one we are looking for in this case. Maybe this is HYP. Now I will later switch to OH and A instead because we can identify the hypotenuse, opposite, and adjacent. So here we can see we've got the hypotenuse. We're trying to find the opposite. We also have the adjacent here as well. We don't have a length for it, but it's still good to label. But for this question in particular, we are trying to work out the value of the opposite and the hypotenuse. So we need to use a formula on the right-hand side that has both the opposite and the hypotenuse. If we look at this, on the right-hand side, sine has the opposite and the hypotenuse. So that is the formula that we are going to use. Now we've said it's sine of the angle, which in this case is 30, is equal to the opposite divided by the hypotenuse. I would still write the formula so we can see clearly when we substitute in. Sine of 30 is the opposite, which is P, divided by the hypotenuse, which is 8. Now, to solve a question like this, we need P to be the subject. P is not the subject right now, it's been divided by 8. So I need to multiply both sides by 8. If I times this side by 8, I have to also times this side by 8. That gives me 8 times by sine 30, which we can actually write as just 8 sine 30 is equal to P. If we put that on our calculator, we can see here 8 sine 30, close the bracket, is equal to just 4. Equal to 4. Now the question was in centimeters, so we're going to write this as 4 centimeters. Keep those units consistent. And that was our layout. First thing we did is label the triangle. We then identified the formula. We then substituted it in and then rearranged and solved. So let's come to the middle question. Exactly the same principle. I want to find out the value of Q here, this length over here. So first step, once again, is to label our triangle. Always easiest to identify the longest length, which is the hypotenuse. I'm just going to use H from now for hypotenuse, but we can see for this question, we're not looking for H and we don't have the hypotenuse, so we're not going to need it for this. The next one is the opposite. Here is our angle, our opposite is over here. That means Q is the length we are looking for. We are looking for the opposite. And the length which we have in this case is our adjacent, which is our 4.2 millimeters. That means for this question, we are looking for the formula which uses the opposite and the adjacent. We come to our formula. This is opposite and hypotenuse, not the right one. This is adjacent and hypotenuse, again, not the right one. Finally, tan, opposite, divided by adjacent. So, same principle. We first write our formula. This is tan of the angle 55 is equal to the opposite divided by the adjacent. We now substitute in. Tan of 55 does not change. But the opposite here is Q and the adjacent is 4.2. Now, once again, Q is not the subject in this case. It's being divided by 4.2. So I need to multiply both sides of my equation here by 4.2 times by 4.2 times by 4.2. If I do that to both sides, I end up with, on the left-hand side, 4.2 tan 55 is equal to Q, or 4.2 times tan 55. Either of those is correct. Put that in our formula, into our calculator. 4.2 tan 55, close my bracket, is equal to 5.998. So Q is equal to 5.998 millimeters. Now, if I want to put that round it up to either 1 or 2 decimal places, that would be 6.0 millimeters. But either of those answers are okay. Okay, very last question on the right-hand side. We've seen our process for each of these questions always being the same. We first label, identify the formula, substitute in, rearrange, and solve. This question is going to be a little bit different though when we rearrange, and you will notice this in a minute. First thing we're going to do, as mentioned, is label our triangle. First thing, hypotenuse, longest length is R. That is the value we are looking for. We are looking for the value of R. The next length we label is the opposite. The opposite is opposite the 21, which is here. We don't need it for this question. And then finally, we look at the 6 meters, which is our adjacent. So for this question, we do not need the opposite. We come to the right-hand side. This equation has the opposite. This equation has the opposite. This is the one that doesn't have the opposite. This is adjacent, which is 6, and H, which is R. So when we write down our formula, we're dealing with cos of 21 is equal to the adjacent divided by the hypotenuse. When we substitute in, you'll notice in this case, we get cos of 21 is the adjacent, which is 6, divided by the hypotenuse, which is R. Now, in this question, it's a bit different because the value we're looking for, R, is on the bottom of the equation. For R to become the subject, it needs to be on the top. So what I'm going to do here is multiply both sides by R. If I times by R over here, and I times by R over here, the R is going to go on the bottom, and it's going to end up giving us R cos 21 is equal to 6. Now, that's still not R as the subject. This is the same as R times cos 21. So to make R the subject, I need to divide both sides by cos 21. So over here, we are going to divide by cos 21. And over here, we are also going to divide by cos 21. That gives us, on the left-hand side, just R on its own is equal to 6 over cos 21. Now, if we do this on our calculator, once again, we get 6 divided by cos 21, which is equal to 6.43 meters. R is equal to 6.43 meters. Now, I can be confident in my answer because R represents the hypotenuse. The hypotenuse needs to be the longest length. 6.43 is larger than 6 meters. A lot of the time, a very common mistake here is people will end up multiplying the 6 with the cos 21, just like we've done in these questions. If we try that on the calculator over here, 6 cos 21, you get a value of 5.6. R cannot be 5.6 because it's supposed to be the longest length, and 5.6 is less than 6. You have to be very careful when you're doing a question when the unknown is on the bottom to make sure you rearrange it correctly. So if you've got a length that doesn't make sense, for example, your hypotenuse is less than your other length, you made a mistake. You need to go back and check your working. You might also notice that to go from this line over here to this line down here, the R and the cos 21 have actually switched positions. When you've multiplied by R, the R's come up. Then when you divide it by cos 21, the cos 21's come down. So these are switched positions. That's another thing which you might get more comfortable with as time goes on. But here are our 3 examples. I've shown you the key steps, which is to always label the lengths first, choose your correct formula, substitute in, and then rearrange and solve, either by multiplying or dividing. I hope that's made sense. If it hasn't, please comment below or let me know. Thank you.